what we found was that mankind had been grossly overestimating the amount of geological or natural fossil methane emissions. And what this means is that we have therefore been grossly underestimating the human caused emissions from the fossil fuel industry. The answer to that is that we go to the polar regions where little samples of the Earth's atmosphere have effectively been sealed off in bubbles in the ice, and they're gradually going down in depth through time. So if you drill into the Antarctic or the Arctic ice sheets, you're basically going back in time, and it's possible to bring that ice to the surface and extract small bubbles of air, little samples of the Earth's atmosphere as it was in the past, and to then analyse the actual composition of that air. And here at ANSTO, we take it one step further and we analyse the isotopes of the individual components of those air samples. Okay, there are two main sources of methane. There's biogenic methane produced by the decomposition of organic matter, and there's so-called fossil methane. It's also produced by the degradation of organic matter, but that methane has been locked up in the Earth for so long that the radioactive carbon, the carbon-14, in that methane has decayed away. And so we can tell fossil sources from biological sources because the fossil sources have got no carbon. Well, ANSTO is one of the few laboratories on the planet capable of making the precision measurements on such very, very small amounts of carbon. And we've developed that capability over 3 decades of work. The good news story is that methane is low-hanging fruit in the sense that we can potentially do something about our methane emissions. And whatever we do to decrease our methane emissions will have a much more immediate effect than decreasing carbon dioxide emissions, because methane is a very potent greenhouse gas, but it has a very short lifetime in the atmosphere compared to